Welcome to Mysterious Encounters. Have you ever felt like you were being watched, only to turn around and find no one there? What if the universe itself is watching? And what if the very act of observation, of simply looking at something, fundamentally changes what you see? This isn't a plot from a science fiction movie. It's a cornerstone of modern physics, a deeply unsettling and profound principle known as the observer effect. Today, we journey into the bizarre and beautiful world of the quantum realm, a place where the rules of our everyday experience break down and reality itself seems to bend under the power of our gaze. Prepare to question everything you thought you knew about existence. Our first stop is one of the most famous and mind-bending experiments in all of science, the double-slit experiment. Imagine firing tiny particles, like electrons, one by one at a barrier with two thin parallel slits. Behind the barrier is a screen that detects where each electron lands. If these electrons were like tiny marbles, you'd expect to see two simple bands on the screen corresponding to the two slits. And when we place a detector to watch which slit each electron goes through, that's exactly what we get. But here's where it gets strange. If we remove the detector and don't watch, the electrons behave not like particles, but like waves. They seem to pass through both slits at once, interfere with themselves, and create a complex interference pattern on the screen, a series of many bands, not just two. It's as if the electrons knew they weren't being observed and decided to act differently. The simple act of looking forces them to choose a path, to collapse from a wave of possibilities into a single definite particle. This bizarre behavior leads us to the heart of the measurement problem in quantum mechanics. A quantum system, like our electron, can exist in a superposition of multiple states simultaneously. It is both a particle and a wave. It has passed through the left slit and the right slit. Think of it like a shimmering, delicate bubble of pure potential. The moment we try to measure it, to pin it down and ask, "Where are you?" the bubble pops. Our observation interacts with the system and forces it to collapse into one single definite state. This isn't a flaw in our equipment. It is a fundamental feature of reality. The Copenhagen interpretation, one of the oldest frameworks for understanding this, suggests that there is no objective reality independent of our measurement. The properties of a particle don't exist until we measure them. The universe, at its most basic level, is an interactive dance between the observer and the observed. This strange quantum dance isn't just a theoretical curiosity locked away in physics labs. It is the powerhouse behind technologies that are poised to reshape our world. Consider quantum computing. A classical computer bit is either a 0 or a 1, but a quantum bit, or qubit, can be both 0 and 1 at the same time thanks to superposition. This allows quantum computers to perform calculations at speeds that are unimaginable for even the most powerful supercomputers today. The entire process hinges on carefully manipulating these quantum states and then observing them at just the right moment to get the answer. The observer effect is also the key to unbreakable security through quantum cryptography. If a spy tries to intercept a message encoded in quantum states, their very act of observation will disturb the states and collapse them, leaving behind an unmistakable trace. The sender and receiver will know immediately that they've been eavesdropped on. Security, powered by the fundamental laws of physics. So, what does this all mean for us, for our perception of reality? The observer effect forces us to confront profound philosophical questions. Does a tree fallen in a forest make a sound if no one is there to hear it? Quantum mechanics takes this a step further. Does the forest even exist in a definite state until someone is there to observe it? This raises questions about the role of consciousness itself. Do we need a conscious mind for the quantum wave to collapse? Or is any physical interaction enough? Physicists are still debating these questions. But what is clear is that we are not passive onlookers in a pre-written cosmic play. We are active participants. The act of observation is a creative act, collapsing a wave of infinite possibilities into the single concrete experience we call reality. The line between you, the observer, and the universe, the observed, blurs into non-existence. As you look out at the stars, remember that in a very real sense, the universe is looking back, and your gaze is helping to shape what it becomes. Thanks for watching Mysterious Encounters.